Today, we're diving into a fascinating story of innovation, straight from the factory floor. We're going to talk about smart saws and how an amazing international team taught a massive, powerful machine something pretty incredible: how to think.
At its core, this is all about a simple but really powerful idea: taking a machine that does a brute force job and giving it a digital brain. And what's really cool is that it's a story of collaboration that crossed borders, connecting experts from Turkey and Hungary to solve a problem that manufacturers face everywhere.
So, before we get into the solution, we've got to understand the problem they were trying to solve. And believe me, in the world of heavy industry, it's a big one.
I mean, just look at this machine. It's an absolute beast, built to slice right through solid steel. But for all its muscle, it's basically blind. It has no idea when its blade is getting dull, or if it's under too much stress, or when a critical failure is right around the corner. And that kind of uncertainty, it costs a ton of money, time, and materials.
So this was the big question they asked. What if, instead of just waiting for something to break, the machine itself could tell you, hey, my blade has about 50 square meters of cutting left before it's done, or you should probably slow down the cut speed for this type of steel. That's the huge leap from a dumb tool to a smart partner.
Now, to make a leap like that, you need the right team. This was definitely not a one-company job. It took a really specific mix of skills from people across Europe. And here's the crew that made it happen. First, you had Bekemak in Turkey, the master builders who actually make these incredible saws. Then you had their Turkish partners, İletişim Yazılım, who were the code breakers, right? The AI wizards tasked with building the machine's brain. And so importantly, you had ZEH in Hungary, the field agents who actually use these machines day in and day out. They brought the real-world know-how and were the final testing ground. Just a perfect partnership.
Okay, so how did they actually do it? Well, the very first step in teaching machine to think is to give it a way to feel. It needed senses.
The project zeroed in on these two models, a giant bandsaw and a high-speed circular saw. The idea was to create a system that could work for both, just to prove how versatile it was.
And this is just a great way to think about it. Before you can have a brain, you need a nervous system. You need some way to get information from the world around you. For these saws, that meant outfitting them with a whole bunch of high-tech sensors.
And the data they gathered gets incredibly specific. This little sensor here, for example, measures the microscopic bending or deflection in the saw blade while it's cutting. That's one of the first and most critical signs that a blade is starting to fail.
And here's another key piece of the puzzle. This is a load cell. It's basically a highly sensitive scale that measures the raw cutting force. Is the machine struggling? Is the metal harder than it should be? This sensor gives the answer in real time.
And oh, it did not stop there. They measured everything. The temperature right at the cut, the tiniest vibrations in the machine, how much electricity the motor was pulling, you name it. They were building this incredibly rich, detailed picture of the machine's health second by second.
Okay, so now you have the nervous system collecting all this amazing data. Now you need the brain to actually make sense of it all. And that is where the AI comes in.
And that brain has a name: Bekemak. You see, this wasn't just some research project. It's the actual commercial product that came out of all this work. It's an AI system built to do two main things: predict failures before they can happen and tweak the machine's performance on the fly.
So here's how this awesome feedback loop works. 1. The sensors feel what's happening. 2. All that data gets sent to a cloud platform. 3. The AI models crunch all the numbers, looking for patterns that mean wear and tear or inefficiency. And then, number 4, this is the magic part, the system actually sends new instructions like tweak the cutting speed right back to the machine's own controller. It's a true closed-loop intelligence system.
Now this might be one of the biggest breakthroughs of the whole project. See, before, maintenance was just guesswork. You'd say, a blade probably lasts 100 hours. But cutting thin aluminum is totally different from slicing through thick stainless steel, right? The Bekemak system flipped that on its head. It switched to a volume-based prediction, calculating the blade's remaining life based on the actual square meters of material it's cut. It's a huge shift from guessing to knowing. And this wasn't just some off-the-shelf algorithm. The team did their homework. They rigorously tested multiple types of AI models to see which one was the smartest. And as you can see right here, for this machine, the XGBoost model was the clear winner, with over 93% accuracy in its predictions. That's the hard science behind the smarts.
So, we have the team, the sensors, and the AI brain. But what did all this actually lead to? Well, the results are seriously impressive.
Here it is, the headline number. By predicting wear and optimizing the cuts in real time, the project got a more than 25% increase in the life of the cutting tools. For any busy factory, that means huge savings on expensive blades and way less downtime.
But the wins didn't stop there. Because the machine was running so much more efficiently, it used 25% less of those cooling and lubrication fluids. The total cost for every single cut dropped by up to 15%. And get this, because the international collaboration was so successful, they brought this tech to market a full year ahead of schedule.
But hey, don't just take my word for it. This is a quote from ZEH over in Hungary, the people who actually use this thing every day. They confirmed that the results were meaningful and blew past their targets. That's the ultimate proof, right? It actually works in the real world. And this is the final piece of the puzzle. This amazing technology isn't just a prototype anymore. Bacamac was so impressed with the results that the Bicamine system now comes standard on their most advanced XS model machines. It went from an idea to a project to a product you can buy. And that really brings us to our final thought for the day. This project took one of the most basic, fundamental industrial jobs, cutting a piece of metal, and made it incredibly smart with data and AI. It really makes you wonder, what other simple task in our world is just waiting for that same kind of leap? What are we going to teach to think next?